Okay. Today we are continuing the materials. We are starting with the data analytics, and for the first time, we will to learn about the data descriptions. You can check with your Ukrida virtual class. I've posted about the materials in a PowerPoints and the three kind of data. Yeah, you can be exercised with this one, with data number one, data number two, and data number three. And I give you time for 1 day. It means that 24 hours to submit your exercise in this button. So you can trying with yourself. You can use with your we are using the Microsoft Excels just for the simple for the starting point that we need to be check that ensuring that you are having a good knowledge and you have a good time for exercise in data analytics using the Microsoft Excels. So before we start the exercising, we have to inform at the first about the new materials in the business analytics. We are starting with the data descriptions. And for these ones, I have sent or posting with the material ebooks in your virtual class, and you can check about the business analytics with the data analysis and decision makings. And this one is the part number one. So we starting with the data descriptions. As the first time that we need to learn about the data descriptions, you need to know about the goal of these materials in the first sessions. In the first sessions, we need to have finished about the how to present your data in statistics or in the data analytics. In these parts, in the descriptive statistics or descriptive models, you need to present or you need to show about your data to make sense about the peoples, including with the three kind of the presenting data, like the graphical, the numerical measure, and the table of the summary. For the first part is about the graphicals data. You will use about you can choose with the familiar chart like the bar chart or maybe a pie charts. If your data will be constructed in a percentiles, you can using about the pie charts, or you can use about the histogram, also the scatter plot and the time series graphic. If you have a data with the numericals measures, you can present in accounts or in a percentage, and with the advanced statistical analysis using the average or the variability. And the end of the summary of the data, you can present into the tables that will be concludes about the totals of your data, the average of data, or maybe with the counts or group by the category that's data that you have, and to be challenging about to how to summarize and how to inform what is the meaning of the number between your statistics. So in the data analytics is a challenge to you how to summarize your data mostly in a numerical number and how to stand out clearly with your analysis. That is the goal of our sections. Before we start the goals of our section in data descriptions, we need to separate, divide about your informations, or like the populations and samples. I think that if you having some engagement with statistical models, you will learn about the name of populations and samples. The population is different with the samples. While the populations, we include all of the entities that will be observed in our data. So let me to repeat that the population, it means that you need to include all of the entities or all of the samples. that you have interest to be observed in your data. It should be containing about maybe lots of the people, lots of the number of potential samples, a lot of the data like the invoices, the number of the business models, and you will be divide your samples, your populations into the any kind of samples. We talk about the samples because not all of the populations we can analyze this. For examples, if you want to check about the trends or maybe the interest of peoples, for example, all of the peoples in the Philippines, you cannot do that because there's lots of peoples that will be taken for the generate about your data. So you need to creating with subsamples or maybe in kind of in the micro samples about your populations. So the sample is a subset of populations that you need to pick with randomly, or you can randomly choose by the representative. You need to may you need some criteria, or maybe you need to eliminate with some possibilities to uh, reducing from populations into samples. For example, if you have to be make some consensus in the Philippines, so your population is all of the peoples in Philippines, and you have the specific sample, maybe only one province in the Eastern Samar, or in samples for your peoples in your university. So that is the differences between a population and samples. So the sample is a micro unit for the populations. Okay. Next, we need to know or learn about the differences between a data sets, variables, and the observations. So the data sets is all of the data, all of the number that you have in your observations. Your observations is containing about the list or all of the list that variable that should be measured in a value. So the variable is taken with the different characteristics. It could be, it concludes by the number of populations or maybe from the samples. For examples, we have to lots of variables like age, gender, or salary, but they have a difference or a random number that should be observed in your data. So we can inform like this one. If you learning about the data like this ones, we have the persons number 1, 2 until 30. We have the different age of different peoples. They have showing about the gender data. We have the states of the livings, the number of the children's, the salary taken by the every peoples, and the opinions. So if we talk about the data sets, that's the number that will be shown in your data. It's a data sets. So what kind of the variables? The variables, it should be taken with the difference like these ones. So we have some information about the age, the gender, the state, the children's, the salary, and the opinion. This is all of the variables. Okay. And all of this number of data, it's called the data sets. This is a data sets. So, and all of the observations between the 30 peoples, we starting in the number of 30, starting for the persons number ones. So we have the 30 peoples of observations, and it's including with the different variables like the age, gender, state, children, salary, and the opinions. So this is the differences between a data sets, the observations, and the variables. Any questions so far? No? Okay,
None, sir.
thank you. Yeah. Next to the types of data. The types of data is consists of two kind of types. We learn about the number of data we call numericals. The opposites of the numerical is not by the wording. We call it about the categorical data. The categorical data it's separates in the two kind of versions, in ordinals or in a nominal. If you have a data with the natural order or in ordering about the possibility value, we name it about the ordinal value. For examples, if you have the level of the questionnaires, like the number one is a disagree and number five is a fully agree, that is the ordinal data. But if you doesn't have a non-natural ordering, we call it a nominal or a binomial. Sometimes we have only two kinds of the possibility, like a genders, if you are a male or a female, if you are study or not study. That's only two options, so we call it a nominal, or in a simples, we also call it in a binomial. B is refers to only two possibilities that shown in your data. In the categorical variables, we also have with the dummy variables. What is the dummy variable? Is variables that could be coded only in the two kind of versions, 0 or 1s. If male will be conclude in a 1 and in others is 0. On the opposites, if you are a female, please create number ones. But if you are not female, is a 0. That is the meaning of the dummy variables. So the dummy variable is actually is a categorical variables that only coded for the two kind of possibility, 0 and 1, or sometimes in 1 and 2. Just only two possibility. We call about the bin category or binomial category. So you can look at these ones. In this data, you can find about the any kind of variables like this ones. This is a variable of a genders. We have only two possibilities, 0 and 1. What is the meaning of 0 and 1? Maybe 1 is a male, 0 is the other of males. Or we can add whether the 1 is a female or 0 is the others. That is the dummy variables. Dummy variables. Okay. And these ones, we also have the categoricals. 0, 1, 2. This is a number or numerical variables. This is also numerical variables because it's containing about the number. But if you see about this one, so we have the opinion, strongly agree, strongly disagree, neutral, and maybe with any kind of the number like a disagree and agree, you can look up with this number of opinions. 1 is a strongly disagree and 5 is a strongly agree. So this opinion will be separate in ordering. From the number, the smallest one is mean that your data is expressing about a disagreement. But with the highest number, for this case is number 5, is expressing about your fully agreement or strongly agree with your opinions. This is we called about the ordinal number or ordinal value because they have the natural ordering for 1 to 5. For the next materials, we need to show you about the kind of number. The kind of number is also divided into positions. One is called a discrete, and the other one we call a continuous variables. The continuous variables means that your number have a continuous measurements. For example, or such as we have a weight or height. Maybe you can show us about your weight. Sorry. For examples, if another one's called what is your height? Weight, maybe you can say that 38.5 kilos. So we have the continuous number in a decimals like this one. That's the how to represent about the continuous variables. But the differences with the discrete variables, like say this is the countable variables that cannot be an in continuous measurements. For example, how many your child, uh, do you have a child or no? And what is the number of your child? You can say that I have one child or two child or maybe three childs. So this is a discrete number. We cannot say that I only have 1.5 child. That is not possible. So this is expressed about the continuous, not in a discrete. So the discrete we cannot express with the decimals or with a continuous measurements. Yeah, I hope it is clear for you. And that's one we need to moving about the cross-sectional and the time series of data. The time series of data, it means that your data is collected over times. Maybe we can learn about what is your inflations in your country starting in maybe in 1980 to 2022 maybe. That one is over times. We only talk about the time. That is the example of time series. The differences with the cross-sectional data is talking about the presenting about the cross sections or a distinct point in the times, like how many province in your country. That's mean that you have the cross-sectional data. That's not refer in a time or in order series of the number that will be collecting and with lots of the possibilities. Okay, how to measures about our numerical data. If you have a numerical data, we can learn about that is the measure or to express or present your data in a different kind of measurements. The symbol of measurements we called about the mean, median, and modes. In statistics, we have the average of the value. The average of value, it means about the mean or represent about the average all of your data. So for the algebraic of the denotations, we need to sum up lots of your data. Maybe you have a 10 data. You can sum of your 10 data and divide with the n number or your 10 number by lots of your populations or maybe in the samples. So if you talk about the mean or the average of the populations or the average of your data, we can use or we can calculate with the function average in your Microsoft Excels. So I think that you are familiar with the Microsoft Excels, all of you, because there is the simple way how to analyze or how to collecting your data and make some simple statistical model using the Excels. The another one, if we know about the middle observations or in the middle value of your data, we call about the median. What is the meaning of the median? The median, if called about the middle of observations. So you need to order your data first. So you need to order or sorting from the smallest to largest. And you need to pick in the middle of your observations. That's called the median. So the median, it doesn't mean that you have a similar value with a mean. Mean is divided by the samples like this ones, but median is only the data is in the position of in the middle of your observations. So let's see that maybe we have okay, maybe we have data in 9 positions. So we have data number 1 to number 9. In the middles, we have data number 5. The data number 5 is called a median. It doesn't mean that data number 5 is same with the average. So the median, it doesn't represents, sometimes it doesn't represent with the average. But if you have the similar value in median and in mean, that you have that is mean that you have good data, or maybe you have a normal data. We call it the normal distributions. It is the presence that you need. You have a similar value for mean and median. In Excels, you can conclude with your median of data using this functions median. The next of your measuring how about the central tendency in the a simple statistic is about the mode. Mode is called the value that mostly appears in your data. Sometimes we can find about the mode number, but most of data are in randomly. There is no mode or no specific modes that sometimes represent in our data. So because that's sometimes it's not very interesting, or maybe that's not a lucky ties that we can find about the mode of the data. But in the Excels, you can find out about your data using the mode notations in your functions will be represented in your Microsoft Excel. The next measurement is talk about the percentiles and the quartiles, or the minimum and the maximums. We start about the simple one, the minimum and the maximum. The minimum is talk about this the short value, or maybe in the very minimum value in your range of data, and we have the maximum value. If you cannot find in your lots of data, you can use with the function in Excel like a min or max. Just in case that you have lots of data. If you only have 10 data or maybe 20 data, that's very easy. But let's thinking that maybe you have thousands data. It's a very difficult to find where is the minimum number and where is the maximum number. You only sort with the function using min or maximums. But the percentiles, it means that you have the percentage of your data. So it means that you need to order your data and divide with hundreds. So the percent in it means that you need to divide your data in hundreds portions. So we call it the percentiles. But in the quartiles, you need to divide your data in the 4 groups and similar number. Maybe a 25%, 50%, or 75%. That's like the quartile 1, the quartile 2, or the quartile 3. So if you can find about the minimum score or the minimum value, and also with the maximum value, you can find out about the range of your data. The range is concludes by the maximum value minus the minimum value. So it's very easy Well, you can find about the minimum value and your maximum value. That's how to find out the range formula in this data or this variance. So, and we also find out about the variance. That is the error of estimations. If you have lots of data, sometimes it contains about the error of measurements. So, is the error is high or not is depend on the score of the variance. So what is the meaning of the variance? The variance means that this is the percentage of your error below or upper your mean or your average data. So it should be represents about the percentage of your error. High variance, that means it means that you have a high error in your data. So for a good representations of the data, you need to find out the data with the minimum of variance number. The variance is typically is in a similar formula between the populations and samples. So you can it's concluded by the mathematical formula like this ones. So there is no differences between the formula, but the differences is only with the minus ones of the samples because the samples is very strictly with the observations, or it means that you can find out the number closely to the average or the mean of your data. It's only for the data that relatively in a small number, not in the highest numbers. Next, we have the portions for standard deviations. The standard deviations in mathematically is only the square root of your variance. What is the meaning of the standard deviations? The standard deviations is means that if you can find about the fundamental problems with the data, the fundamental problems, it means that there is the real error containing in your samples or your populations. So you cannot find the standard deviations by make some square roots for your variance formula. So with this kind of informations, you can try to make some exercise using the data. Sorry, like this ones. You can find out about the mean, the variance, the standard deviations like these ones. If you have data from the diameters of the square root of deviations like these ones, so you can find about the number of your variance, the for the populations, the samples, or maybe the average of your data. The next one is about the skewness. The skewness is to detect it that your data is distributedly in asymmetric informations or not. So what is the possibility if your data is not in asymmetric informations? The symmetric, it means that your data is divided in a normal distributions. For the right side or the left sides is very similar like this ones. We also have bell shapes like this ones for data. So if you divide your data, like but this is the average value, you have the similar value below average and the number value upper the average is very similar or very closely to your mean or your average. That means that there is no skew with your data. But sometimes the data will be divided into two kinds, a skew to the right or skew to the left. Skew to the left, like these ones, it means that your average, this one is the average, your data is containing lots of score upper the average. That means the mean of the skew to the right. Or for the another ones, we have the left of skew. That means that If you have the average, your data is containing the number is mostly below the average. So maybe in your class, let's say that we have 100 students in our class. The data is skewed to the right. So it means, or it can be concluded that the score in our class is containing lots of students that have scored or credit in out of the average, maybe outstanding. This is more for the average. But if the skew to the left, it means that our classes have mostly in the low score, below the average. So this is the differences between a skewness. So you can find out the formula of the skewness in the Excels using the skew functions, and you can find the number in positions like the plus or minus. Plus is containing that you have a right skew, but the minus, it means that you have the left skew with your data. Next is talk about the kurtosis. The kurtosis is talking about the fatness of your data. What is the meaning of fatness of your data? So sometimes if you make generate your data, it should be distributed in two kind of these symbols, like these ones. It's kind of kurtosis, or maybe we have lots of these ones. So this is the fatness of data. This is a thin, and this is the fat data. What is the meaning of thin or fat of data? If you have the kurtosis with a thin data, it means your average scores may be in a short range. Let's say that we have the highest range in hundreds, but the minimum score may be in 80. But if you have the fat range or the kurtosis with the fatness, it's your score will be separate maybe from the 20 as the minimum score until 100 for the maximum score. So the range is very high if you have the fatness of your kurtosis. But if you find out that you only slow of kurtosis or maybe the thin kurtosis, your range of your data will be short or very short than your fatness. This is the meaning of the kurtosis. Okay, how to represent our data if you have the numerical variables. Numerical variables, it could be indicate that you can make some distributions. You can show or represent your data using the histogram, the box plot, or the time series. What is the differences? Histogram is a common type of your charts. If you have the numerical data, not in a bin numbers, this is in a random number and maybe more or sign up to the discrete categories, you can divide it like this one. This is the histogram of the data. It's like bar charts. So histogram is a similar with the bar charts. You can show like this one or maybe with these ones. This is also about the histograms. So we'll be stack it in the very categorials. This is the category number 0, 1, 2, 3, 4, 5 until number 8. You can represent your data like these ones. The next of representing data is about the box plot, or we call the box whisper plots. What is the box plot data? It's like the advanced statistical models. You need to find out the first quartiles, the median, the mean, the third quartile to create about the box. So I think it's a very advancing about the number or advancing with the kind of analytical data. So if I offering to you, most of you maybe doesn't like with this one, with the box plot, because you need to find out lots of informations like the mean, median, the quartiles, and the outlier, or maybe with the range of your data. So it's very simple if you can find or represent your data like the histogram like this one. The next is about the time series data. The time series data, remember our keywords. This is changings, or this is a dynamical tables data that represents over time. It means that you have lots of time of observations. For examples, you can find about the property charts like this ones. It's separate starting for uh 1980 to 20 and tens thousands. So this is the kind of the time series data, or you can represents like this ones. This is the data about the violence and the property crime in US in the 1960 until to the millennium. So it represents over time with the yearly observations. I think more than 1 year or more than 3 years. So this is very suitable for representing your data using the time series of the chart. But remember, some of your data maybe represents in very strictly a point or standing on of points like this ones. It's only in a quarter of the years. You can find about the in a January, in April, in July, in October, and starting again to the January. It's not in a yearly. It's only in a quarter year. So it's a very rich of your data. So maybe your data it's like the lines, but it's very strictly, extremely with the volatility in your data. So this is also with the time series graphic with your data. Okay, after you presenting your data in the kind of the graphicals, we also find out about the outlier. What is the meaning of the outlier? Outlier, it's a kind of data that's outside of the norm. That is kind of with the maybe for the valuable data in a statistical models, there is they're containing very high with the error, very high or standard deviations, very uh, too far from the mean or maybe with the medians. So we call it about the outlier. Sometimes outlier makes some mistakes. Outlier come make some very failure in our predictions or our forecasting, because the outlier is means that the data will be outside of the norm. So we need to exclude this data. If you cannot, if you can find about the outlier data, please you make some corrections, or you can pick out with your the outlier data in your data sets. The next point is about the missing value. What is the meaning of missing value? That you cannot find the number of your data. You cannot find out, maybe you cannot detect it, you cannot make some informations that we call it about the missing value. So if you have a missing value of data, we only have two kind of treatment. You can ignore your data with the missing value. So just leave it with the blank value, not in a zero. Zero and blank is difference. Zero, it means that you have a zero number. But if the blank value, your data will cannot be counted. So for example, like this ones, if you have the number of data like this ones, okay, we have the number one, we have the number one, we have the zero, we have the number one, we have the number one, and we have number one. 1, 2, 3, 4, 5. We have the 5 divided with the 6 because 0 is a kind of number. Okay, this is not a missing value. What is the kind of missing value? If you find about this one, it's a blank, left it a blank. So in this case, sorry, in this case, if you make some conclusions, it's only 5 divide with a 5 data, because it's only 1, 2, 3, 4, 5. Only 5 data have a score. One is a missing value. That one is called a missing value. So just left it blank because the end of observation is difference. This only countable for the 5 observations. But if you fill this data with the 0 numbers, please remind that 0 is still a number. So the denominator is containing to the number of 6 because this one is filled with the value, not a missing value. Is it clear for you? Okay. Any questions so far from students?
None, sir.
Okay, thank you for responding.
Mhm.
So, I give you three kind of the data in here in the virtual class. You have a data number ones about the questionnaires. Data number 2 is talking about the number or maybe the salary. So we can say that's like these ones. Let me to check it first. The data number 1 is containing about these ones. Sorry, this one is a baseball salaries. Okay, this is the data number 1. It's about the questionnaires value. So we have the informations about the person number 1 to number 30. We have the age of the persons, we have the genders, we have the state, the children, and the salary. You can find out. Let's make the examples. Let's find about the average of the age. So the average of age. So we can find about the formula like this ones, the average, and you can track about all of your data, and we can find out the average or the mean of the age is 42 years. Okay, what is the median of this data? Median of age. You can use with the formula medians, like in the PowerPoint. So we can find here, and we can find out about the number 40. How do you know? It's a 40. We have the 30 of data. So in the medium is a data containing in a number 15 and a 16. In a manual, you need to short the data like this ones. So I need to make it up of filtering your data. Short the data like this ones. Short ascending. And in the diff in the middle of data, it's containing the number 40. So this is the median of the data. If you sort your data from the minimum value to the maximum value, we can find out the medians. Data number 16 and 17, because this is a number 1, starting number 2. So this is the median of data, 40. The mean is 42 years old. So the mean and the median is the difference. If you can find about the range in a manual, range in a manual, we can starting with the highest number, 65 minus 21, 44. Okay, let me to Find with the formula range. You can find about the minimum value and maximum value with the score. The minimum value from this one is 21, and the maximum value for this data is 65. So the range of data is 44 because range is from the max minus min. Okay. Any questions so far? How about the skew?
None.
Thank you. The skew or the kurtosis. Let's say the skew. You can try with the skewness. The skewness, you can make functions of the skew and drag with the edge. 0.44. What is the meaning of 0.44? The skew of data is average on 44 years and the mean is 42 years. So it means a positive. What's the meaning of the positive? The positive, it means that you have a right skew. Your data is containing most of the sample over the 42 years old. So the samples that have the age out of the 42 is most in the your data. Okay, like that one. So you can continue about the exercise using the data number 2 or data number 3. I need to continue about these materials using the uh, finding relations between the variables. Okay. After you find out about the description of data, we need to make some comparisons between your data. The comparison means that you need to compare with your first of data or the second or maybe lots of more than two of data. So that we can find about the format of data like a stacked or unstacked data. So the differences between the stacked or unstacked data is about the similar value. You can see this one. The stacked data is containing with the a similar group of data like this ones. If you cannot find the gender and a salary, we have 22 data of gender and the 22 data of salary. This is the format of a stacked data. But the format of unstacked data, it consists of a different number of data. For example, the female salary, for the female salary, we only have 13 data. But the male salary, we have a 10 data. So the total of data is 23. So this one is only 22, missing one of data. So this one is, this one is 22 of data because the number one is not counted in this data. So this is the differences between the stacked and unstacked data. If you cannot find with your similar data, it could be a stacked data. But sometimes we cannot make the data in a similar format like this one. The most of data is represent in unstacked data. So you need to build up your data into this one or stacked data. So most of the data is not available in a stacked data. So you need to transform your unstacked data into stacked data. Next, how to make a graphical with the dots or the scatter point. We call it about the scatter plots because we need to denote any point or any observations will be selected in our chart with the engage with the variables. This one is the kind of the scatter plots. You can find the scatter plot if you have the two kind of axes, x-axis and y-axis. For examples, we have the x-axis for the events and the y-axis is about the age. This also the similar with the y-axis of age and the x-axis is about the earnings of data. So you can create with the scatter plot data like this one. So we can predict that, oh, this one or this data is uh, represent in a random number or in a random possibilities. If you have data that should be in a fit model, you can make a trend line between your data like this ones. This is a scatter plot that we have for the x-axis or and y-axis. And if you make some predictions model, you can create a strike line like this one, strike lines numbers, and we can find about the trend of your data. So for this informations in from the scatter plots, we can make some conclusions that your data will be represent in a decreasing value of driving accuracy. More of accuracy is mean that you have the differences value in a trend of reducing about the yards of the driving data between your driving accuracy data. So please denote that your scatter plot having a different kind of trend analysis or the trending of your data. For the next sections, we also make some informations about the correlation and covariance. What is the mean of correlation and covariance? Correlations means that you have a relationship in your data. It between two kind of variables. It could be strong, it could be not in a strong positions, but sometimes it's the positive positions or a negative positions. It's below from the informations would be show up about the cluster and the strike line rises that will be represent from the relationship and the creating some direction for your linear relationship numbers. For the model of the Excels, we using about the correl functions or the correlations functions. And for the covariance, we also needs about the cofar functions in Excel's points. So this is for the examples that you can find about the data, or you can trying about the difference number from the exercising. So please check with your virtual class in here. You have data 1, data 2, and data 3. What is your next activity? Your next activity is try with lots of functions that will be selected or represents in your materials today, starting with the main, medium, modes, and until we with correlations, the correl and the covariance. So please try make some graphical chart. You can use with the histogram, maybe you can make with the pie charts, or what kind of analysis that you can show to the other peoples. So we can conclude that you can maximize or you can analyze with your data or with the data that's given to representing that you can do with the minimum functions in Microsoft Excel using the data analysis. So I give you a day for exercisings. You can do in this Excels, and you can upload your Excels in this one, in this models, in this uploads buttons. So in these ones, you have the submissions. You can upload your file, but I make some notations that only one file can be uploaded. So you need to combine all of your analysis only in one file. So only in one file. I know this is separate in three kind of data. You can make all of this data, data one, data two, and data three, or you just only make with you can trying with only with one data. That's depend on you. It's up to you. But for the key points or in the goal of this sessions, I can ensure that you can use with the formula in Excel. So please try exercise with this data in Microsoft Excel and upload, and I give you 24 hours to try with your data. I think that's all for materials today. And if you have any questions, you can ask to me in this class before I close the sessions.
None, sir.
Okay, thank you for responding, Sita Bells. 1, 2, 3, 4. Who is missing? Hyacinth. Hyacinth is not coming. Okay. Any information from Hyacinth?
We don't know, sir, because we are from Borongan and he's from B1 and C.
Oh, okay. I will take some notes about that. Okay. Okay. Before I close the sessions, I will remind you again that you have 24 hours to make some exercise and upload with your file to your virtual class. And we will meet again in the next sessions for the next Monday, and we will trying with the new of relationships using the correlations, the covariance, and the another material after the descriptive statistics. Thank you very much for coming until the sessions, and I hope you can enjoy the learning and you can have a self-studies using the exercise, and we will meet again in the next sessions. Thank you very much for coming, Clinis, Citabel, Venice, and Oliver.
Thank you, sir.
You're
Thank you, sir.
welcome.